Now let's see the simplest synchronization mechanism, which is lock variable. So even though the name says it is lock variable, it is not actually lock. Okay, let's see this first. Now it is a software mechanism, which means we don't need any support from the hardware, which is implemented in user mode. So what is user mode and kernel mode is, if you need any support from operating system, then we need to go into the operating system code, that is called kernel mode. And if you don't want any interference from operating system, then you can do it in the user mode. So user mode means we don't need anything from the operating system, we can write it in with our own code. So if you need any help from operating system code, that is called kernel mode. And now it is a busy waiting solution. So what did I say about busy waiting solution? The other person will keep on knocking, that is busy waiting solution. And it can be used even for more than 2 processes. Many of the solutions, they work for 2 processes, and some of the solutions they work for more than 2 processes, and it is such a solution where it will work for more than 2 processes. It works this way. See, what did I say about the mechanism? There will be critical section in the program, and above the critical section you are going to place the entry section, and after that you are going to place the exit section, right? And now if you watch it, above the critical section, the entry section is like this. So okay, before going ahead, initially lock value will be 0. Lock value will be 0. So lock value 0 means the critical section is vacant, and lock value is 1 means the critical section is occupied. Okay, or lock value 0 means there is no one inside the critical section and you can enter it, and when lock value equal to 1, there is someone inside it, you should not enter it. Okay, so now watch it. While lock value is not equal to 0, which means as long as lock value is 1, there is someone inside, right? Therefore look at the semicolon here, it means you are going to be in infinite loop. As long as lock value equal to 1, you are going to be in infinite loop. You could even write it like this, as long as lock equal to 1, right? Because here we are going to use only 2 values, one is 0, other is 1. You need not write not equal to 0, you could even write equal to 1. Then you are going to be in infinite loop, you are going to be here itself, as long as lock value is 1. So that is why I am saying that it is busy waiting, right? And then when lock value equal to 1, then if lock value equal to 0, then what happens is this loop will break, and once you break the loop, then you are going to make lock value equal to 1, so that you are stopping others from entering. Got it? And then you will enter into the critical section, and once your work is done, you are again going to release the lock, right? Even though the name says lock, it is actually not going to lock the critical section. The critical section will still be open and anyone can enter it. Okay, let's see how it works. Let's go to our metaphor where I am comparing this critical section to a room. Now assume that critical section is again a dressing room, and there are not just one person. The solution is applicable for many people, right? So let us say there are 4 people. Okay, 2 girls and 2 boys, and now they want to use the dressing room, right? And dressing room is going to have a door. Okay, and now how does this one work is, it is not actually having a lock, right? So if this is the knob, the door knob, then to the door knob we are going to hang a tag. That's it, hang a tag. It is exactly similar to that your dressing rooms you might have seen in malls. So there you will see that if someone enters it, there it will show that it is occupied. If someone comes out, it will show that it is vacant, right? And sometimes the knob, that there will not be any lock, right? Maybe you can think of it as the dressing room in Zara showroom. If you have seen the Zara showroom, there they don't have any locks, they just have a curtain, right? You can think of it that way. So anyone can enter the dressing room while you are inside, right? So now see what happens here. So how does it work is, now you are just going to hang a tag. Initially the tag contains, this is the tag, not the lock, just the tag. I am just hanging a tag to the knob. Initially it will be vacant, right? Then how does this mechanism works is, if this person wants to get into this room, then he will first check the knob and the tag whether it is vacant or not. Yes, how? He will check it whether it is 0 or not. If it is vacant, which means if the lock is 0, then he is going to replace it with the other tag. He will have one more tag and he will take out this tag and then replace it with the other tag, which will say occupied, which means lock equal to 1, and then he will enter the room. Yes, he is now inside the room, right? And now at this time, when anyone tries to enter the room, then now they will check that the knob contains the tag occupied, therefore they will stop themselves from entering. That is how this entire mechanism will work. But then the funny thing is, they will not enter it, but they'll keep on knocking it, right? So what does this knocking really mean is, maybe you can think of it this way. See this? Assume that process P1, let's put the line numbers here. It is line number 1, line number 2, line number 3. Okay. Now process P1 has checked for the lock, and initially assume that the lock is 0, which means process P1 is out of the while loop, and then it has locked it, lock equal to 1, and then it has entered the critical section. And at this time process P2 has come for execution. This got preempted. P1 got preempted, and now it's the turn for P2 to run. Now what will P2 do is, P2 will initially run line number 1, and now it is saying that if lock not equal to 0, yes, lock is not equal to 0, you be in the infinite loop, therefore P2 is going to be in the infinite loop in line number 1 forever. And even though the CPU wants to execute P2, even though CPU is trying to execute P2, it will not be able to do anything else, which means P2 is still at the CPU, yes, but then it is not doing anything, it is simply in this loop. So CPU is busy, process is doing something, but it is not doing anything, it is simply waiting, right? So it will keep on, being in this line number 1 forever until this P2 comes out. Now let us say, P1. Now P1 exited, which means P1 has executed the line number 4, and now it went out. And again, if P2, now if it gets a chance, now it will execute line number 1, and it will come out of it, breaking it, and therefore it can execute line number 2 here, right? And then enter into line number 3. Now if you watch it, this is what I am calling as the busy waiting. Why is it called busy waiting? Is P2 is getting the CPU to get executed, but then it is not getting anything to execute. It is simply staying in the loop. So it is busy doing what? Waiting for what? For the other process to come out, right? That is called busy waiting. Got it? And P1 now that is why I am saying that it is a busy waiting solution, and it is implemented in user mode, right? And it can be implemented for any number of processes. Now the problem with this is, I'll tell you a problem. So how does this tag work is, assume that initially, assume that this has happened. Initially no one wants to enter into the room, and therefore no one is inside the room, and when we start the program, we are going to start it with the vacant tab. The tag is containing vacant symbol, which means anyone who wants to enter it can enter it. Therefore now this person has come, and now he has seen that, oh, it is vacant, right? And he is just about to change the tag, which means he executed this and he came out, and he is just about to execute the second line. But then suddenly assume that we pulled him away, someone called him, it is nothing but CPU preempted him, right? Now he went again back into the ready queue, and at this time the next process came here, right? And now she will also see that this is vacant, isn't it? Now she will think that, oh, it is vacant, and therefore I can enter, right? So what she will do is, it is vacant, therefore she will replace it with her tag. She got a tag with her, and she will say that it is occupied. It is occupied, and therefore she will enter inside the room, right? Fine. And now what happens is, after some time, again this fellow will come for execution, which means he will get scheduled, and again this fellow will come here. And now what he remembers is, last time when he saw that the tag is vacant, therefore he is not again going to look at the knob, he is not again going to look at the tab, right? He is just going to, already has checked it, last time he has seen that it is vacant, therefore he still thinks that it is still vacant, right? That is the problem. Now what happens, Now he will take, without seeing that is a vacant tab, sorry, occupied tab, he is going to remove it and then replace it with a new occupied tag, and he is also going to enter, right? Which means he will replace this old tag, he will take it out without seeing what it is, he will take it out, and again he will replace it with a new occupied tag which he is having, and now he also enters, right? So actually the lock variable is not a lock, it is kind of tag, right? And the problem is, at the same time many people can see that it is vacant and they will get preempted, and next time when they again get the chance, they all will enter into the room, right? So at any time, how many people can enter into the room? All of them. How? Everyone might have seen the tag as vacant and they might have got preempted, and next time when they get a chance to execute, everyone will enter into the room, right? So at the same time n process will enter into the room, therefore there is no mutual exclusion provided. If there is no mutual exclusion provided by your solution, there is no point in discussing about any other things, because that is the most important thing. If it failed at the basic necessity, then we are not going to discuss about the other things. It is simply a failure method, right? So we are not going to use this method at all, right? So in case if they ask anything about it, the lock mechanism doesn't provide any mutual exclusion, right? And deadlocks and all, they are secondary. We don't want to even talk about it. If it failed at the basic step, first hurdle itself it is not able to cross, why do you want to talk about the 3 more hurdles, right? It is failed, right? And now I think you understood the example, right? I don't know whether it is a good example or bad example. Anyway, my intention is just to make the points clear, okay? So don't worry about the kind of example that I have given you. Maybe it is not a good example, it is up to you. And anyway, I think you understood it well. So now coming to this instructions, how is this possible that 2 processes can be inside at the same time is, watch it. Now initially lock value equal to 0. Now let's see in this, in terms of this code, how is it going to not ensure mutual exclusion? I think you understood with the example, right? But then let me show you how this code, in terms of code, how many processes can enter into the critical section at the same time. So at this high level language, is a high level language, right? While loop and then the assignment. At this high level language, it will be very difficult for me to explain it. So let me convert it into a low level language like assembly code, and there it will be easy for me to explain you things. Let me convert it first. So if for this one, I think if you remember compiler design, there I have told you how to convert a high level language program into assembly language code. So for this while loop, maybe it will have instructions like this. First we are going to load. Step number 1 is load. Load means we are going to run copy load lock variable into that, whatever the lock variable is, into some R0. See, I'm not talking about any particular or specific assembly language. I'm just writing it in a normal way, generic way. So these instructions might not belong to any particular assembly language, or they might not be at all in any language at all, completely not a particular language or no language at all. So but then there will be some instructions similar to these instructions in every assembly language, and they will be generated in place of these. So if you could analyze with these instructions, the same thing could be done in any programming language, any assembly language. Now first we are going to load the lock value into R0, which means R0 is going to contain the lock value, and then now I'll compare R0 with 0. You can either compare with 1 or 0, not an issue, right? So with 0, now the third one is if it is not 0, which means jump, I'll write jump if not 0. J and Z means jump if not 0. If R0 is not equal to 0, which means R0 equal to 1, then I have to again go and check it, right, to step 1. What does it mean? It is a while loop. So we are checking the value of R0, and if the R0 is not equal to 0, we are again going to load it, check it, load it, compare it, load it, compare it. It will keep on happening. When will this loop break? This while loop will break only when lock equal to 0, right? Therefore at some point it might break. So once it breaks, then what should we do? We should store. We should assign 1 to this lock. Therefore store the value 1, right? Okay, just for the sake of syntax, the value, load the value 1 into the lock variable and then after doing this you enter the critical section, right? And after coming out of the critical section, what is it? Again we are simply, is it visible? Again after coming out of the critical section, we are simply going to store the value of lock as 0, which means we are releasing the lock. Got it? This is the entry section and this is the exit section in terms of the assembly code. Now let's analyze how two processes can enter the critical section simultaneously. Now assume that lock variable equal to 0 initially. Then process P1 has come for execution. It is now in the CPU and it has executed step number 1, which means it read lock as 0, right? And then before doing anything else, it got preempted. And then P2 came into execution and then it executed 1, which means it will also read lock as 0, and then it will execute 2. It will compare R0 with 0 and it is equal, right? Which means it is equal, right? Therefore it will not go to 1. This particular step will not lead us to 1, it will simply lead us to 4. Therefore 1, 2, 3, 4, and now it is in critical section, and now it got preempted, which means it is simple like this. In the previous example, in that room case, now P1 has seen the tag that it is vacant and he went away, and now P2, she came and now she has seen the tag and the tag is saying that it is vacant, therefore she changed it. Where did she change it? Fourth line, right? She replaced the tag with the occupied tag and then she entered the room, right? And now again P1 came. Now when P1 comes, he will not again look at the tag. That is the problem. Without looking at the tag, he will remember that I have already seen it to be vacant, and he compares with that vacant one and he thinks that it is vacant, and again he is going to do this, which means P1 is going to do 2, 3, 4, and then he is also going to get into the critical section. Why did this happen? Because he has observed the tag last time, and he now thinks that still the room is vacant, even though it has been changed in the middle, right? So what has happened is he is not checking it again. Understood this? So at the same time P1 and P2 will be inside the critical section, but you can even prove that all the process can be in the critical section. How? P1 will look at instruction number 1, preempted. P2 will look at instruction number 1, preempted. P3 will look at instruction number 1, preempted, so on. Pn will look at the instruction number 1 and preempted, right? Then what happens? Everyone will load into their registers, that lock variable is 0, and next time when they get scheduled for execution, everyone will happily go into the critical section, right? So in that room case, everyone has seen the vacant tag, and before they enter the room, they got pulled away, and next time when they go there, they are not going to see the tag again. They are directly going to enter the room, right? So that is how there is no mutual exclusion provided by this solution. So this solution failed big time. So if there is no mutual exclusion, you need not worry about any solution at all. I mean any other conditions at all, right? Fine, that is all about the lock variable.